So we're here, but I believe we're having audio problems. So could you let me know in the chat if you hear me?
I can hear you.
All right, well, I don't think I can hear you. All right, yeah, I just turned the camera on so you can see me now, or you can at least see the board.
Looks like everybody's muted.
Excuse me?
Looks like everybody's muted.
I'm not.
But you said you couldn't hear them, that's probably why.
No, when I ran the testing for it,
Oh,
I'm not hearing it. So. And I'm also seeing that the audio on this display is on. Is that on? It shows laptop for audio. And we don't want audio on laptop. Oh, wait, it was grayed out. It's not grayed out. All right, I bet I can hear them now.
Hello, can you hear me now?
Yep, I can hear you now.
Perfect.
I don't know about that, but. All right, so I believe this is where we left off. Is that correct?
yeah.
Yes.
I guess.
Okay, so some of you escaped. Some of you have to see me more than once on a Monday and Wednesday. But there is I had printed out and I still, well, maybe I don't have any with me now. All right, so there is a pre-class quiz and you will need to, I guess, pull it off of D2L. All right, before we get too far started, a couple of bookkeeping messages. I have a few classes this semester. That is sarcasm. All right, so when you send me an email asking me something, would you please do me a favor and tell me what class you're in? So especially if it's put it in the subject line, and you don't need to include the engineering prefix, you could just say 220, where's the homework Dropbox or something like that. But if I don't know what class you're in, I don't know what to direct to whom. Does that make sense? All right, that being said, gotten emails about homework and about, I still need, no, who wants Cengage? Oh, that's 2:30. So I've gotten emails about homework and about pre-class quizzes. Is anyone in this group, do you guys know how to turn in a pre-class quiz virtually? I'm looking at you, Zoomers.
I'm not sure, no.
Okay, all right. And I appreciate you telling me that, because it's better you tell me that than we have miscommunication later. So let's get into the class. And those of you that have taken multiple classes from me, you can go ahead, close your eyes, put your head down. We're not going to spend too much time doing this because we have a lot of fun problems to get to. Right. So you go into D2L. You can do it through the PIMA dashboard. How else do you guys get into it? You don't know? It is going to be d2l.pima.edu. Can you see, Brian, can you see my D2L screen?
Yeah, I'm already there. I have the pre-class quiz and all that pulled up right now.
Oh, okay. So, if this is your first day or whatever, we are Engineering 220. So that is your name. You will notice that okay, let me correct that. I attempt to make sure that I send out an email that looks something like this. Right, so you will see announcements and then you will also receive it as email. So I'm trying to be over communicating. Okay, and through this, and this board wasn't working yesterday. For example, right, if we click on here, this goes, click on it again, or open a new window. What does it want me to do? I guess that. Okay, so this is then the lecture from Monday. All right. So if you miss a class, it's not the end of the world. It just means that you need to go back and watch the videos. All right. So if we go to content, pre-class quizzes are here. This should not be 2, it should be 12. I don't know why my brain did that, but 12.2, 12.3, I wrote 12.4, I will make you a video on it. All right, but 12.2, 12.3 is here. If you go tools and then you go assignments, so there are 2 important parts, assignments and quizzes, and you go assignments, and you go down and it says pre-class quizzes, and then you can upload it here. So 4 people uploaded it. If you plan to come to class, you can certainly come to class, or you can be virtual on any particular day. Same thing with this. If you want to turn it in paper, pencil, great. If not, that's fine. And that reminds me, Max, are you with us? Because that was another email. But Brian, did that answer your questions?
I think so, yeah.
Okay, yeah, so it's under, you go tools, and then here, I don't think you see some of these, do you? You go to, oh, I know you don't see that. Here, let me be a student. Oh, I don't want to deal with Chrome. I want to be a student for Pima. It's the wrong button. All right, here. Okay, now you're seeing things as a student. If I go tools, you still see class projects and classes. All right, so assignments and quizzes are the 2 we're going to focus on. There will be no discussions because this is either virtual or in person. So we have nothing to discuss. Or you can bring it up during class, right? All right. What is the deadline for pre-class? Pre-class quizzes should be done the day before. All right, so Andrew has a good question in the chat. Pre-class quizzes, and then I'm going to address another question that I received. Pre-class quizzes should be done the day before. So you should have done the 2.3, 2.2, 2.3 pre-class quiz prior to coming to class today. All right, but I also, as you all know, oh good, Lorenzo is here. How you doing, sir? Good. As you already know, I have an open late work policy. All right, so as long as you get it to me by December, our last day of class is the 15th, right? By December 15th, it will still be graded, no penalty, because you all have lives, you have work, you have other things you have to worry about. Flip side of that is that pre-class quizzes will get you ready for what's going to be lectured on. All right, and so the 2.41 that I posted and that I have here is the purpose of this one is to get you ready for us dealing with some different coordinate systems. Okay, so it's just, and there should be reviews. They should take you maybe 5 minutes. Andrew asked about registering for Pearson. Do we have a prepaid access code? No, you have to buy it. I do not have the manpower or student power, I should say, be able to do that. Yes, I'm aware it's expensive. So homework has 2 options for homework. Okay, that is the correct book, Andrew. You don't have to do your homework online. Now, a lot of people like online homework because they can see solutions, they can watch little videos, it'll take you to similar problems. Other people find online homework a total nightmare because the answer is 12.198 and they put in 12.2 and it gets marked wrong. All right, so there are two different camps. If you would like to buy the book, you can buy it used. If you would like to buy a used book and do the homework, paper and pencil, you can do that and you can then upload it here in assignments. Okay, and I will get the Dropbox. Well, here are the drop boxes for homework, but I will get these drop boxes set up for you. All right. So does that make sense? Now, I'm sure, Andrew, you're going, cool. I can get this a used beat up copy for, I don't know, $50 or something. All right. So, but how do I know what homework problems to do? Well, there is this amazing thing. By the way, here is the PDF of, here is the PDF of the syllabus, because it seems to be your operating system on whether or not you can get in to see the syllabus or not. Because they were playing with it in Fluid yesterday. All right, so, and there were 3 people sitting next to each other. One couldn't get in, but the other 2 could. If you click on this fall schedule of classes, you will notice, Andrew, that you have 12.-16, 17, 18. That's actually 2.2. And then 29, 46, 51, 52, 58. That's really 2.3. So, Andrew, when you see this, that are the problems in the book. Okay, so those are the book problems you would do if you want to use the book and not the e-text. If you use the e-text or you use the online homework system, you don't have to care about these problems because those will be the ones that will pop up. Does that help, Andrew? Does that help everyone? Okay.
I think we still need like the access code though, because when I log into mine, I don't get anything.
Is there a classroom?
You have to buy it.
But so maybe there's a code that links that purchase to.
Oh, don't log in that way. Okay, now, thank you. Thank you. And I want to call you Logan, and that's wrong. And now I want to call you Andrew.
That's closer, Anthony.
Anthony. So what you will do is do not log into Pearson. You go access Pearson here, and then you hit this launch tool, and that will link it to the class. Okay, and then you open this one here. I don't know if you see that in between screen or not. Okay, so, and this is my homepage, but that is how and then you'll see here is the homework. All right, but that you get to it through D2L, not through Pearson.
For some reason, when I do it that way, it loads that initial home screen, but when I click on either the yellow button or the links below it, it doesn't do anything at all. Like nothing pops up.
Okay, so this homework setup is new to me. If you would send me some screenshots, I will send it to Tessa and we will figure out what's going on.
Okay.
Is that fair?
Yeah.
Okay, very good. Okay, anyone else tried to get into the Pearson? I might have set something up wrong. No one's admitting to it? Okay.
Got in, I was able to see it.
You're able to see it?
Yeah, the first 2 showed there.
The first couple? Okay.
Yeah, I don't think the others are visible, but I saw them first.
That's weird because they should all be open. You will notice there are due dates on these, but I will accept them through the end of the semester. The reason I have the due date as September 17th is that is the day of your first exam. So I would recommend you do some homework before your first exam. In fact, I would recommend you do some homework out of 12.2 and 12.3. I don't know where 12.4 went. That's weird. But I would recommend, or maybe we skipped 12.6. I'm not sure now. I would recommend you do some homework because next Wednesday, a week from today, we're going to have a quiz. Monday, we don't have class. So please do not try to log in Monday and then get mad at me. I will not be here. I will be on a boat off the coast of Mexico. Not thinking at all about you folks. Okay, and that's me being obnoxious, but I will be on a boat. Well, let's see, it's 1 o'clock on Monday. No, I'll be driving. I will be racing back to the border to then sit in line for 4 hours. So they let me back into the country. All right, if they let me back in the country, we'll see. All right. So does that help with how the class is going to work? So you have pre-class quizzes, you have group work, which we don't have any today because I'm going to lecture today. Typically Mondays is group work day. And then you have proctored or in-person quizzes. Take them online, take them here. It doesn't matter where you take them. Okay. And then we have 4 exams, 3 exams.
4 plus a final.
4 exams and the final. All right. So you have plenty of opportunity to show me your brilliance. All right. So this is where we left off yesterday. Is that or not yesterday, on Monday? Is that correct?
Yep.
Where we were talking about what the average speed is versus the instantaneous speed. And I'm assuming, did we do average velocity and instantaneous velocity?
I have that written down.
Yeah.
That's all you've written down.
that
Okay,
exactly.
that's cool. That tells me exactly where we are. That is fine. So, as I said, all right. So, what do we know? Let's back up just a little bit. Okay, what do we know about velocity as it's relative? Well, we've got it here. So let's look at variables. What is S?
Distance?
Distance. But what type of distance? Let's be careful. What type of distance is S? Okay, it's displacement, but it's a scalar. It's strictly a number. Okay, so when we talk about speed, whether it's instantaneous speed or average speeds, this is based on just a number. It is not a vector. This is then the difference. Let me go back and review what we did. Okay, this is then the difference is if we have average velocity. That's right, their blue pen doesn't work in here. Man, I'm gonna put a ticket in. There will be lots of tickets up here. All right, average velocity, and I've lost my VPN. I know, I probably already complained about that. I can't approve faculty contracts from home. I have to come to campus to approve faculty contracts. All right, average velocity. Velocity, the word velocity starts with a V. That's not helpful, but it means we're now dealing with a vector. Okay, so it is the average. That is then going to be the change in R over the change in time. Right? Time is not a vector. Time is linear unless what? When is time not linear? There was actually just a big discovery about this.
Quantum thing.
Yes, a quantum thing, right? So they found that in quantum mechanics, when the particles are first generated, they can actually go back in time. So time is not linear on a quantum scale, but for us as engineers, it is. Okay, all right. So V average is then change in R vector over change in T. That's going to give us the average velocity. Now we're dealing with a vector, correct? That vector is going to have X, Y, and Z components. If we're talking about instantaneous, sorry, I can't spell. And why is Anthony the only one talking to me today? Valerie, cat got your tongue?
I talked a little bit.
Oh,
He talked at the same time though, so.
Yeah. I'm
oh,
probably
gotcha.
talking over me. That's a problem.
Oh, okay, I got it.
It's a fine line between being insufferable and being quiet.
All right. If it's instantaneous, then we are looking at it being dr dt. R is our distance vector. All right. So you learned, maybe not, but let's play with this for a moment. If I tell you your R vector is 7 in the I direction plus 2t in the j direction minus t squared in the k direction, could you tell me the velocity at any point in time? If I want the velocity when t equals 3, could you tell me when that is?
Yeah.
What would we have to do to get there? Take a what? Calc 1. Take a derivative with respect to t. Is this coming bringing back some bad memories yet? Martine was like, oh yeah. Okay, so if I want the velocity, and we talked about this notation, now your author does this, I don't like it, but I'm gonna learn to deal with it. All right, Brian's got it, derivative, yes. What we're gonna do is we're then gonna take the derivative with respect to t of all of these parts. Okay, if I had more than a t in there, if I had ty, what would you do with the y? Hold it what? You would hold it as a constant because we're only interested in the derivative with respect to t. All right, so let's look at what would happen here. If we're taking the derivative with respect to t of 7i plus the derivative with respect to t of 2tj minus the derivative with respect to t of t squared k, derivative of a constant is 0. You don't have to write your zeros down. What is the derivative of 2t? It is 2. What is then the derivative of t squared? 2t. So if I put 3 into this equation for time, you would then see that it would ultimately equal 6, right? The t, and that would be its velocity at that particular point, or the velocity vector at that particular point in time. Okay, so by the way, if we go back to this, if we know my velocity vector, this is my velocity vector, what is the derivative of the velocity vector?
Acceleration.
Acceleration. Then what, that's also then the second derivative with respect to t of our r vector. So those dots have a name and they're called tensors. Back on the cave-walls with the dinosaurs, right? We wouldn't write it as a dot and a vector because a dot means I'm taking the derivative of a vector. So I'm not sure why the author does that. I guess he likes to over communicate as well. All right, so 2 dots means we're taking the derivative twice. Always, a tensor is a derivative with respect to time. Okay, so that means I can then go in and take this derivative again. So, well, we're gonna 0i, I'll just go ahead and write it down, plus 2j minus 2tk. What is my acceleration vector then? Right, it's going to be negative 2k. Now this is interesting because that means my acceleration vector is constant. In your physics 210 classes, your acceleration was constant, wasn't it? It's not always going to be constant now. All right, but in this situation, it is constant. And we went a little bit off base. All right, so if we can take derivatives, can we go the other way? Yes, we can. All right, so. Oh. Acceleration, and then I have constant acceleration. All right, so let's go ahead and we might skip some of that. Let's talk about our equations of motion. How many of you back in Physics 210, well, I shouldn't say this because I'm not sure exactly what goes on because I've never taught that class, sat there and memorized a ton of equations? Oh, you got an equation sheet. Okay. All right. So if we talk about the equations of motion, and we're going to make it a little more advanced. Differential equations of motion. All right. Sounds a little scary. Not really, but we'll go for it. So let's start with velocity, right? We already talked about how velocity is then going to be d r over dt. Let's not integrate vectors. Let's back up just for a moment. All right, let's look at it in the terms of speed. How many of you have completed Calc 3? Okay. Then I guess we could integrate the vector. But let's keep our lives a little nicer right now. So velocity is change in distance over change in time. So this was the first part of your pre-class quiz. Okay. The way you would solve this is separation of variables. That is a DiffyQ topic. It should be your first DiffyQ topic, or you might have dealt with it at the end of Calc 2 or Calc 3, or no. It depends on who's teaching it.
Calc 2, I remember seeing.
Yeah. Okay. So when we have separation of variables from a differential equation point of view, okay, what that means is it means I can split stuff around. So the first problem on that pre-class quiz is a separation of variable problem. I'm going to treat the derivatives as if they're almost like they're algebra. So I'm going to rewrite this so it's ds v dt. Okay. Welcome to separation of variables. If you have x's and y's mixed together, you just move all the y's to one side and all the x's to the other side. Are you guys all in DiffyQ right now, or have you already done with that class too?
Already.
Yeah. You're done? What, are you in it right now?
I finished.
Oh, everyone's finished it?
I'm in it.
You're in it. This should be the first topic you did?
We're working through it.
We're working through it. Okay. Okay. But it is basically, it's an algebra type is how when I teach it, that's how I teach it. Okay. So that means what? That means we're looking at the fact that we can then integrate this one here from our starting point to our ending point. We can integrate t from 0 to t, can't we? Right. When we do this, or actually, let's not make it 0. Let's be more generic. In fact, I'm gonna change my variables on this. All right. I'm gonna integrate it from position 1 to position 2 equals the integral from time 1 to time 2 of v dt. Okay, hopefully you don't get freaked out when I erase something. Did I tell you I had a student who used to do that? It was like college algebra or something. She'd get really angry at me whenever I made a mistake and I erased something. She'd tear the paper out of the notebook, sigh, and be extremely dramatic. I hope she was a theater major, because that's where she belonged. Not a math major. All right, So this is S2 minus S1. We all agree, actually, we'll write it out. Oh my, that was scary. Let's try this again. Oh, now I've shifted. Sorry online folks, something happened. I don't know how I did that, but that was cool. I'm gonna try not to do that again. This is too big. Okay, that's better. All right. So when we do this, the integral of ds is just going to be s evaluated from S1 to S2. This one is a little bit more complicated. If b is a constant, it just comes out front, doesn't it? So we really have two cases here. I'm doing it again, I'm erasing. Case one. Promise, I'll get my act together, maybe. Case one, we're going to have an S here evaluated from S1 to S2, right? Then you're going to have to do this integral, b dt. This occurs, case one is when v is a function of time. So velocity is changing with time. That's a little different for this class, because I bet back in physics, right, you did this. We'll call this one, I really want the blue pen to work. We'll call this one case two. S is going to be the same. So we're going to go from S1 to S2, but now B is some constant, right? Let's say it's 100 miles per hour. It's just some constant, ds. If it's a constant when I integrate now, I can pull that v out of the integral, can't I? I see me's, but I think that was over Cal 3. All right, so I can pull this, v out of the integral because he's a constant. And what do we end up with? We end up with S evaluated from S1 to S2, then equals VT evaluated from T1 to T2. S2 minus S1 then is going to equal V times T2 minus T1. Now, you might be saying to yourself, that equation looks a little familiar, but not quite. Is anyone saying that to themselves? So in the land of physics, this is going to become, we're going to call it S naught, which basically means the distance at t equals 0. And in the land of physics, we're going to say T1 equals 0, right? So the physics people, we always start with time 0, and then we have our displacement time. So we end up with this equation, S minus S naught. We can leave the 2 in there. That's time. That's fine. V times T2 minus 0. Well, would you look at this? Does that look very familiar to you?
It's a kinematic equation.
Right, it's one of the kinematic equations. All right, assuming that we're starting at 0, we can do the same thing with acceleration. All right, which is actually was supposed to be then this slide here. All right, what do we know about acceleration? We know acceleration equals the change in v with respect to time, correct?
Touch me.
Yep, what's up?
Go back.
Where do you want me to be?
Just at the bottom.
Dr. Moon.
Yeah.
So it would be for case one, it would be specifically V of T, dt.
Right, so you would be given, in fact, here, let's look, let's jump ahead. All right, so if we jumped ahead to this example, now I have V as a function of T. So to get the displacement, in fact, let's do this one problem. Now I'm looking at, let's go ahead and just do this, right? So, and then we'll talk about acceleration. Unless, do you want to go through acceleration equations for differential equations, or should we jump to this? Vote! E, for example, in the chat.
We're here, let's do it.
We're here, let's do it. What do you guys think? Lorenzo, you're the tiebreaker. What should we do?
Let's do it.
Let's do it. Okay, we'll make him benevolent dictator for the day. All right. So what happens is we have a car moving in a straight line. Straight line means we have what? What were we calling? What was the title of this class? Rectilinear? Yeah, rectilinear kinematics. Okay, we're going to start curving stuff on Wednesday, I hope. Okay, so where T is in seconds, determine its position and acceleration. First step to problem solving. What are we given? I am given this V. Second step to problem solving. What do I want to find? I want to find position and I want to find acceleration. Okay, if I have V, how can I get the position? What do we know about position and V? V is what? V is ds dt, correct? All right. We know it moves in a straight line. This, it tells me it's going to start at 0. Oh, it tells us when t equals 0, s equals 0. So that's how we're going to set up our integration. All right. I want to see you set up your integration for these. So, because you can't use those wonderful equations you were given by the lazy people in physics. I shouldn't say that because I give equations too, but. Okay, so I'm going to integrate. I'm going to go from 0 to some s. Why is my bottom limit 0? Because of that right there. I'm then going to integrate this from what to what?
Sometime.
0 to some time. Time is given to us as 3 seconds. So we're going to go from 0 to 3 seconds. Is V a constant in this problem? No. So therefore, we're going to put the equation in for V. All right, so we're integrating from 0 to s ds equals our integration from 0 to 3t squared plus 2t dt. All right, we're integrating. So this just ends up being s evaluated from 0 to s. Integration. When I integrated t squared, what do we get?
3t to the third over 3.
Right. We got a question, Lorenzo, or are you just thinking? Okay. All right. If I'm integrating a t, that's going to become 2t squared over 2. This is then evaluated from 0 to 3. Okay. So we end up with s is then going to equal, can I not write it out with the 3s because we all know, or not with the 0s? Well, it's okay. So what do we end up with? We end up with 3 cubed plus 2 squared. Actually, this is a good question if this freaks you out enough.
Plus 3 squared, right?
Oh, you're right. Now I owe Valerie extra. I have a tendency when I'm integrating from 0 to something of ignoring what I am. What is happening there? Okay. So this is going to end up being 27 plus 9 27 plus 9, help the old lady, 36. All right, 36, and it's gonna be then 36 feet. So it goes about a third of a football field in 3 seconds. All right, are we comfortable with how that happened? Now for this one, we can also do the acceleration, right? Because acceleration is what relative to velocity? It's the derivative, isn't it? So we know our acceleration equals dv dt. So for this one, then we're going to take the derivative with respect to time when t equals 3. And now I've lost the equation. What was it? 3t squared plus 2t?
Yeah.
Do they use this type of notation? I don't think they do. I don't think Stuart uses that notation. That just means I'm going to take the derivative and plug in t equals 3. That's all that means. Okay. It's like the line means, in math, a line means evaluate at. All right, so if I take this derivative, I get 6t plus 2. We're interested at t equals 3, so that's going to give me 12 plus 2, which equals 14. This is then going to be in feet per second squared. The t here is in feet per second. When I take the derivative is in seconds, isn't it? So that's where the other, that makes no sense. That's where the other second is coming from. Go ahead.
12, isn't it 18?
Yeah. I was getting ahead of myself. I wrote down the 2. 20. All right, let me see. Valerie, and now I owe Anthony money. Anthony extra credit points.
Either one works, I guess.
Either one works. Why don't you just adopt me and then I can take classes for $15 a semester?
Yeah.
Okay. So, make sense on how we did these problems. Yes,
And that's 20 feet per second? Or
square,
feet per second squared, right?
because it's
Okay.
acceleration. All right, so one of the seconds comes from the velocity feet per second. The other second comes because I took the derivative with respect to time. That's where that second is coming from. That's a tongue twister. Try to say that really, really, really fast. Are you bored or are we doing okay? Okay, so those on Zoom, if you're doing okay, I need a thumbs up. If you're not doing okay, give me a thumbs down. So classroom, same thing. You're doing okay, thumbs up. You're not doing okay, thumbs down. Don't let your neighbor influence you. Gibran, I do not see a thumb. Okay, you're mixed. Brian's giving me a sweaty face. Yeah, it is hot in here and I probably am sweating because it's really warm. Ray, Kevin.
I think that was a salute.
Oh, it's a salute. It's not a sweaty face. As you can see, I spent a lot of time sending emojis. Melody, why don't you try to log into 219? That's a mystery. Go ahead.
Why didn't we do the same process when it comes to the acceleration for the velocity?
Okay.
Like the differential equation, right? Like separating them?
Oh, I see what you're saying. So we have just let's take a little step back, right? We have position, which is S. Okay. If I take the derivative of S, I end up with the velocity. If I take the derivative of the velocity, I then get the acceleration. So whether you're going to integrate or take the derivative depends on what the question is asking. If I give you a position problem, This is a position problem, isn't it? Right? If you're given a position problem and you want velocity and acceleration, you're gonna have to take the derivative twice. Right? Or you also know that acceleration is d squared s over dt squared. You're taking its derivative twice. All right? Which we need to go back and look at acceleration real quick because there's an equation that the author uses a lot. I don't remember seeing it written this way in physics, which is why I want to make sure that you guys all get a chance to see it. All right, so, but my physics is sketchy on a good day. It's just been a long time. So ds dt, it gives us velocity, or we could find acceleration either way. So if I have velocity and I want to get position, what do I need to do? If I want to go from here to here, I'm going to have to integrate, right? So that's why we integrated to get position, and then we took a derivative to get acceleration on this one. So watch what you're given, basically, all right? And I think that's going to come back on the next one. Let's take just a moment and talk about acceleration. All right, and the derivatives associated with acceleration. I don't think we need it for this problem. Let me go ahead and do this problem if we want. That one's fine.
Do we need to go back and finish what we were doing?
Yes, we do. That's what I was just mentioning. All right, so we know that acceleration is then the derivative of the velocity with respect to time. All right, there is another way, so we can do the same thing on this. We can do acceleration times dt then equals dv, correct? So what is that called in DPQ?
Separation.
Separation of variables. Who's taking 260? You're probably going to need to be doing this also in 260. Has he thrown any derivatives or anything at you yet? They're coming. All right. All right. So if we, what'd you say?
I was telling him what 260 was.
Oh, 260 is for mechanical or aerospace engineers. Apparently you're offended when I tell you that you're the same person. But you are. V1 to V2, which then is the integral of a dt from T1 to T2. It is introduction to electrical engineering, but it's not for electrical engineers. It's for mechanical / aerospace engineers.
Dr. Mickey, we didn't add the dv in the first integral.
Yeah, that'd probably be a good idea. Who's talking to me?
Kevin,
Kevin. You're gonna come to class tomorrow, Kevin?
plan to.
Cool. No, I mean, are you gonna be in person?
Yeah, I plan to be.
Okay.
My schedule kind of fluctuates depending on the day.
No, if you can't be in person, just make sure you have your objects as listed to play with for the group work. That sounded really bad, but it's not. It's we play with marshmallows in that class. All right. When I integrate this, we're going to end up with a v evaluated from v1 to v2. Once again, we have to be careful with what is going on over here. Okay, if acceleration is a function of t, I have to put it in what that equation is for acceleration, don't I? But if it's a constant, I can move it out. So you end up then with v2 minus v1 is then going to equal, and then I'm going to leave this alone because I don't know what that acceleration is. Okay. There is one more, but let's just look at this for a moment. And if we're dealing with the constant acceleration, so this is that case 2. where acceleration is a constant. A lot of your problems in your 210 class is a constant acceleration. When we're dropping balls off of elevators, it's a constant acceleration. All right, so this ends up then, if A is a constant, we then end up, and so if A is a constant, V1, we will say it's equal to V naught, because that's what the physics people like to say, V naught, which then equals A, evaluated from T1, T2, dt. So this ends up then being, oh, and T1 has to be, it doesn't have to be, physics people like to call it 0. So we end up with V2 equals V naught plus AT. All right. The other equation that we're going to have to be able to work with. And by the way, I also give equation sheets, but I don't tell you what they are. All right, so you'll need to at least be able to identify them. In fact, tomorrow, Kevin's going to tell you that solids has a quiz where it's literally a list of equations and they're going to identify when they use them or what they are, because there's so many equations in that particular class. All right, what do we know? We know acceleration equals dv dt, right? And we know v equals ds dt, correct? All right, so we can also look at acceleration as then being, I'm trying to remember because you do, well, I'm just going to write this equation down. Dv ds, but the v is out. But thinking about it, I think for some reason you do a substitution with the position vector, and because you can get the dt's to cancel. I'm sorry, this is a math problem, which
Is that
no one
from the
cares
chain
about.
rule?
Yes. dt over ds. Then the t's are going to cancel. So that would then have to be a over v. Yeah, that's how you do it. All right, yes, it's chain rule. So starting at this point, we can then take it one more step. And that's what I said is I wanted to make sure you saw this set of equations because it seems to pop up a lot in the homework. Once again, we're going to do separation of variables. ADS equals BDV. All right, if we then integrate this from A1 to A2, and we integrate this from V1 to V2. Okay. I don't know how A is going to vary with S, so that one I have to leave alone. But this second one is a VDV, isn't it? So A1 to A2 of ADS is then going to end up being V squared divided by 2, evaluated from V1 to V2. Oh, I see how to do it. Hang on. It just, my brain turned on. And it wasn't 3 in the morning. I know A is dV dt, right? And I know, so we would then have dV dt dt ds. But in order to do that, we would have to then have a ds as well. Right, and so it would, that's where that v comes from. Right, yeah, dv ds ds dv ds ds dt. Sorry, I'm not making any sense over here. Ignore me. There's a reason they don't let me teach math anymore. All right, so when we put this in a1 to a2 ads, this is then going to be v2 squared over 2 minus v1 squared over 2. Once again, this should look a little familiar. All right, we don't know what's going on with the s's, but if we look at this in terms of if a is a constant, all right, then what do we end up with? So if a is a constant, or I'm sorry, that's it, I'm going home. I got 2 more classes to teach today. What, and no one said anything. Y'all just let me go down this primrose path. You're as bad as the freaking DiffyQ students. That's when I started offering extra credit. Should that have been from A1 to A2, people?
S.
It should be S. S1 to S2.
Yeah.
S1 to S2.
Is this
When
where
I-
I rip out a sheet of paper in frustration?
Yeah, feel free. At this point, you certainly can. If A is a constant, we're then going to have S2 minus S1 equals V2 squared over 2 minus V1 squared over 2. This now, believe it or not, looks an awful lot like a velocity equation as a function of position back in your previous classes, because this would be the equation you had in physics. V1 squared equals, and then they, well, not equals, but plus. Slow down. Plus 2a S2 minus S1, right? That equation should look familiar. Does that equation look familiar? Yes. It's okay, you're fine. I'm trying to figure out what that was saying.
Just like going back up, how did we get A equals B? Yes.
By using the chain rule, which is the wrong, which is not a good answer. Yeah, that's why the pencil got just slammed down. Let's see where, I just saw it a moment ago. Yeah, we have to use the chain rule to be able to, so here, let's try it again. We know acceleration is dv dt. Do we all agree on that? All right. So if I then multiply this by dt ds. Oh, now I see how, yeah. And if I then have ds dt. So you would agree that these derivatives would all just cancel, correct? All right. So what is happening though is I'm saying this and this is going to cancel. And I'm saying this here is v, as in velocity. So my a is then going to be v dv ds. Does that help?
Yeah, it's just like kind of scary treating the derivatives as fractions, because I know sometimes you can do that, sometimes you can't. Like get in trouble.
You're not gonna get in trouble in this class. You'll be fine. In fact, I don't think you ever get in trouble. We do that all the time. In DiffyQ, don't we do that all the time? Yeah.
DiffyQ.
Oh, well, in DiffyQ, you will do this all the time. Okay. All right. Okay, so let's now go ahead and do another example. It's a little more challenging, and that has to do with displacement. So let me know when you have this example down. Give me a 6 in the chat when you're ready to go. DVDS represents the change in velocity with the change in distance. That is correct. Got a couple of 6s. How are we doing in the classroom? Logan says we're okay. Anthony says we're okay. I need to learn other names. Gibran, Angelina. I have Jaden. You escaped me.
Trey.
Oh, Atreyu. You moved up a row. Yeah, don't do that. Okay. No, didn't you sit back there in the spring?
Here, then I sat back up here.
That's right. When you were serious about the topic, then you moved forward. We have Christopher. And no, I was looking in front of you. I want to say it's like Naveen or something. Nevin. Okay. All right. So I got the folks down in the classroom. I need to get all the folks online. Melody. I think I already asked you this once. I'm worried I have a bad link. Did you intend to try to log into 219? Or did you only intend to log into this class? I'll send her an email because I saw it pop up that someone logged into 219. And I'm like, that was yesterday. And now I'm worried I have a bad link in the D2L shell. All right. So let's talk about what this is doing. You saw this problem in Calc 1. Maybe. Did you see this problem in Calc 1? I don't know what they're doing in Calc 1 these days. All right. So a particle moves along a horizontal path. All right, good to know. Velocity, v equals 3t squared minus 6t meters per second, where t is in seconds. If it's initially located at 0, determine the distance traveled, the average velocity, and the average speed. All right. Now, there are two different things going on here that we have to worry about. When we talk about the distance traveled, right? This guy is moving what? He's starting at the origin and he's going backwards. What is happening at this point? Okay, you can think of it as an inflection point. What is happening to the velocity at that point?
It's going to 0.
Velocity has to be 0. This is the part that you do back in calc. Velocity here has to be 0. And then he's going to come around and he is going to move out. And so we have to figure out both of what is happening there. All right. You can think of it this way. He moves to the left 4, then he's going to actually move to the right 4, and then he moves again, another 6.25. So when we look at the distance traveled, we don't really have to do any complicated math. You can think of it as the little thing on your phone or watch that counts your steps, right? Even if all I am doing is walking back and forth in this room and it's counting my steps, it doesn't care that I'm not actually getting any closer to Phoenix, does it? Right? It's just counting the steps back and forth. So let's talk about what happens. We're going to head to the left by 4 meters. That is that -4. But if you think about it, we're heading to the left by 4. Let's write it out. Then I head to the right by 4. Then I head to the right by 6.125, don't I? So the distance traveled is then 4 plus 4 plus 6.125. So that's then going to equal 10.125 meters. Right. The key is that there is a difference between the distance traveled and the displacement. Okay. Displacement is how much closer it is to Phoenix, so to speak. So when you see a problem like this and it wants the distance traveled in 3.5 seconds, you can read it right off of this. But if it's the displacement, then we have to do the problem differently. The reason we care about the displacement is because of the velocity. So if we're looking at the displacement, that is physically our delta S. So that is then going to be the S when t equals 3.5 minus the S when t equals 1. Or sorry, not 1, but 0. Okay. So the displacement is then going to be what on this problem?
6.25.
6.125. He could spend all the time he wants messing around over here, but he's not getting anywhere until he decides to go this direction, correct? So the displacement from t equals 0, for displacement, you don't care that it heads backwards and then retraces its steps, right?
Dr. Minky?
Yeah.
Shouldn't the distance traveled be 14.125 in case we're gonna use that number later?
Yeah,
Yeah. I only saw one form. I don't think we use that number later, though. That's a different problem. Okay. So, but do we agree, though, the displacement is 6.125? All right, so that is how much distance got changed. The reason we care about the words here is what is it when we find, by the way, what are we flying? Average velocity, average speed. Okay. Because when we're going after our average velocity, which, by the way, it's not a vector this time. So when we talk about average velocity or average speed, oh, let's talk about what the difference is. Average velocity is then displacement over time. All right. What is my displacement on this? So that is then 1.75 meters per second. Right. The speed is a little different. So I was discussing how one's a vector. Right? When you're in your car and you're driving to Nogales, let's say, right? You have miles per hour, correct? So your speed is your total or your distance divided by time. So that is why we found our distance, which was what, 14.125. Right, divided by 3.5. All right, and that I got 4.04. Anyone else get that?
Yeah.
Meters per second. All right. So we are out of time. I don't know why in my brain I thought we went till 2:15. That's when the other class starts. One thing, and this, I got a question about this and the pre-class quiz. All right, so on the pre-class quiz, I wrote something like y equals f prime of x, and then I gave you a graph, right? And let's say, because we're gonna start doing this now graphically. Let's say I give you a graph that looks something like this. This is then your f prime of x. All right, versus x. If I want to integrate this so I get capital F, and I think I called it y again, but if I get capital F, how am I going to integrate that? What's it going to look like? We just did this in statics, people. It's how we found shear and bending moments.
Well, that's a straight line, so it's the slope.
Right? It's going to be a slope, isn't it?
So just stop there.
No. Well, okay. It's going to go up and then it goes to, and then it's going to have to go back down, I guess. Yeah, that's right. Okay. So
I was wondering if it was 0, but just go straight.
that's the derivative of that, right?
Integral. So it's some constant. Integral of
But it's
0.
constant. It's going to come straight down. Is that what you're telling me?
No, I thought it was gonna go straight horizontal. Some constant number that stays the same.
Yeah, I have to think about that.
Yeah, I'm not sure either.
I know it has to come down when we do shear and bending moments because our shear and our bending moments at the ends of the tubes are zeros. All right, so that should answer the question on the pre-class quiz. On the backside of the first pre-class quiz, I want you to take that line and then give it to me as if you were integrating it graphically. We are going to start now. We're going to go in, and that's what we're going to do on Wednesday is we're going to do problems graphically. All right, we're going to start learning how to do them using graphical analysis. All right. And then we need to move into curve linear. We're already behind. Here is the next pre-class quiz. All right, we'll do graphical. Expect to take an in-person quiz on Wednesday. If you are taking it virtually, please take the practice exam virtually. Is that there? No, I'm not. Virtual students, you are dismissed. Have a good day.
Hey, Dr. Mickey,
Yeah.
on the during the respondents lockdown, asked us to tell you if we had any problems with links. Both of the links that I had led me to the Desmos calculator, and I think one should have led me to the Desmos matrix calculator.
Got it. Okay, so I need to check on those links and make sure they go to the calculator.
Yeah,
So
I
it's
think
telling
both
me-
took. Yeah, both took me to the calculator.
Oh, and one should have taken you to the matrix calculator and one should take you to the regular calculator.
Correct.
Okay. I will go in and we'll fix that.
All right, thank you very much. Have a great
You're
day.
welcome. All right, you guys have a good weekend, safe weekend. Don't add to the population, don't subtract to the population. If you end up in jail, establish dominance quickly.